In this video, we're going to complete example 1. It says the numbers below belong to the set of rational numbers. Show that each number is rational by expressing them as a fraction in the form a over b, such that a and b are elements of the set of integers. Now, if you're somewhat confused by the notation that I'm showing here, it might be because you've missed the previous video. And in the previous video, we mentioned that rational numbers are basically numbers that can be represented as a fraction. And to be more specific, this fraction will be in the form a over b, such that a and b are basically whole numbers. So we're just saying we can't have a fraction where you've got 2.1 over 3.6. These are not whole numbers, they're decimals. So we can't have fractions like this, but we can have fractions such as 2 over 3 or even negative 4 over 5, because the set of integers, this symbol z, means whole numbers that are either positive or even negative. Anyway, let's get started on the example. We're going to turn these numbers into fractions. Starting with question A, we've got 0.3. Notice that we've only got one number after the decimal point, and I'm going to make that the numerator for my fraction. And then for my denominator, I'm going to have 10. One digit after the decimal point means we need 1 0 for our denominator, hence why we've got 10. To turn a whole number such as 5 into a fraction is really simple. We just need to put that over 1. 5 divided 1 is 5. Moving on to question C now, we just need to take out that decimal point so that instead of 2.18, our numerator is going to be just 218, being careful to put that negative out the front. Now you'll notice that we've got 2 digits after the decimal point. 2 digits means 2 zeros for our denominator, so we get 100. Now moving on to question D, we've got 0.507, we're going to write that as a whole number, 507, putting the negative out the front. Then for our denominator, we have 3 digits after the decimal point. Our denominator needs to have 3 zeros as well, giving us 1000. So we'll now move on to question E on the next slide. And these questions are getting trickier. You'll notice they're trickier because they've got this repeat symbol. All right, we'll start with question E now. The first thing we're going to do is we're going to make x equal 0.8 repeater. Next, I'm going to multiply both terms by 10, like so. Now, x times 10 is really simple. That's just 10x. What happens when you multiply a repeated decimal by 10? Well, to illustrate this, I'm going to write it up above, except I'm going to write 0.8 repeater with lots of 8s, like so. When I multiply something by 10, it moves the decimal point one place to the right. What's that going to give me? Well, it's going to give me 8.888 repeating. So down here, I'm going to write 8.8 repeater. I've now got two equations. And what I'm going to do is I'm going to use the elimination method. I'm going to write one equation on top of the other. So I'll start with the equation 10x equals 8.8 repeater. And instead of using the repeater symbol, I'm going to write my 8s down several times. The second equation I have is x equals 0.8 repeater. So x equals 0.8. And I'm just going to keep writing my 8s down for a little while. The reason I'm doing this is it just helps me illustrate what's happening here. Now, using the elimination method, I'm going to subtract the two equations. The left-hand side is really simple. 10x minus x is 9x. What do I get when I subtract the right-hand side? In particular, what's going to happen to these 8s that are repeating? Well, you might notice that 8 minus 8 is 0, 8 minus 8 is 0, and these 8s are cancelling each other. And they're cancelling each other forever as we move to the right. So all I really need to do here is just go 8 minus 0, which is 8, because I know that the rest of the 8s are just cancelled. Now I have an equation that doesn't have a repeating decimal, and I can solve this equation now, quite simply by dividing both terms by 9. This leaves me with x equals 8 over 9. So I've answered question E. I've converted this repeating decimal to a fraction. But I would like to check it. Is 8 over 9 the same as 0.8 repeater? Well, I just need to divide it. 8 divide 9 is 0.8 repeater. Excellent. All right, let's now move on to question F. We're going to start off in the same way. X equals 0.37, where both the 3 and the 7 are repeated. What am I going to multiply both terms by this time? Am I going to multiply them by 10, like I did in question E? Well, let's look at what happens when I do that. To help me illustrate this, I'm going to write this number down without the repeater symbol. So I'm just going to write 3s and 7s down for a little while, like so. And then I'm going to multiply it by 10 just to see what happens. I know that it's going to move the decimal point one place to the right. It will leave me with 3.737373 and so on. I'll write it down below, but I would like to line up my decimal points. There's a really good reason for doing this. The reason I'm doing this is because when I subtract them, the decimal points need to line up, and you'll notice that the 3s and 7s are not lining up in the correct way. I really want my 3s to line up and my 7s to line up so that they cancel each other. Timesing by 10's actually not going to work here. Because I've got two decimals here, I need two zeros. I need to times it by 100. What's going to happen when I times it by 100? Well, it's going to move the decimal point twice. This will leave me with 37.3737 and so on. Now, lining those decimal points up, it's going to look like this. 37.3737 and so on. And now we can see that the 3s line up and the 7s line up, which is what I want. I want to be able to cancel all these repeating numbers. All right, so we know that we need to multiply by 100 this time. The reason we know that is because I've got two decimals repeating, so I need two zeros. For the left-hand side, 100 times x is 100x. For the right-hand side, as we mentioned before, when we times 100, we get 37.37 repeater. 37.37 repeater. So we're going to use the elimination method. We're going to write one equation above the other. So starting with 100x equals 37.3737. Once again, I'm just writing down these repeating decimals one after the other to help illustrate what's going on. I write down the second equation, x equals 0.3737 and so on. Making sure that the decimals line up. Let's subtract these two equations. 100x minus x, that's quite simple, that's 99x on the left-hand side. Looking at the right-hand side and focusing on the recurring decimal we have here, you'll see that the 7s cancel, the 3s cancel, which is exactly what we want. We want to cancel the recurring decimal so that we get a number that is not continuous, a number that finishes, I guess. So 37 minus 0 gives us 37. We can now solve our equation. We divide both terms by 99, giving us x, which equals 37 over 99. Now bringing up our calculator to check this, 37 divide 99 gives us 0.37 repeater. Perfect. We'll now move on to question G. So once again, we make x equal this number, and we're going to make x equal 0.03, and it's going to repeat. Now you'll notice that we've got a negative there. For now, I'm going to leave the negative out. I can put it in at the very end. We've only got one number that's being repeated, so that says to me that I only need one zero, meaning I only need to multiply by 10 this time. What's that going to look like? Well, we'll illustrate it up above by writing this recurring decimal down except several times. So we'll write it down 0.03333, and so on. What happens when I multiply this by 10? Well, it moves the decimal point once to the right. That's actually going to leave me with 0.333 repeating. So down below, I'm going to write 10x because I'm timesing by 10, which means on the right hand side, I'm going to have 0.3 repeater. Now I need to write both these equations one on top of the other. So we're going to have 10x equals 0.3333 at the top, and x equals 0.0333 repeating at the bottom. Now we need to subtract these two equations. The left-hand side is really simple. 10x minus x will give us 9x. On the right-hand side, we need to cancel these repeating decimals here. You'll notice we're left with 0.3 up above and 0.0 below. 0.3 minus, well, this is basically 0, will give us 0.3. Alright, now we need to divide both terms by 9, cancelling the 9, giving us x equals 0.3 over 9. Now we're faced with a little bit of an issue here because, as we mentioned earlier, we can't have a decimal for either our numerator or denominator here. Now this is an easy fix. All we really need to do is multiply them both by 10. Because when we multiply 0.3 by 10, we get 3 at the top, and 9 times 10 is 90. Now I'd like to double check that this works. 3 divide 90 does give me 0.03 repeater. Remembering that we actually want it to be a negative. So what I'm going to do is I'm going to write my final response up above. I'm going to say that 0.03 repeater is 3 over 90, but we need a negative in front of the 3. Now this might confuse the marker a little bit because all our working out involves not using a negative. So I'm just going to highlight my negative fraction to show the marker that this is my final response here. Anyway, we'll now move on to question H. Obviously, we need some more room here. So we'll create a blank slate, and we'll start by saying that x equals 2.9102, and the 102 is going to repeat. What do I multiply by this time? Well, I've got 3 numbers that are repeating. That means I need 3 zeros. I need to multiply both terms by 1000. So for the left side, I'm going to have 1000x. What's it going to look like on the right hand side when I multiply by 1000? Well, we'll write this down. 2.9102, 102. We'll repeat this several times. And if we multiply by 1000, we're going to move the decimal point 3 times to the right. This means we're going to have 2910.210210, and so on. So I'll line up my decimal points, 2,910.210, 210, and so on. 210, 210, and so on. And we can see that this lines up quite well. The 1s, the 0s, the 2s are going to keep on cancelling. The 9 and the 2 won't cancel, but that's fine. We can subtract that. It's going to work quite well. All right, so 1000x equals 2,910.210 being repeated. So let's write one equation above the other. 1000x equals 2910.210, 210, 210, and so on. And down below, we're going to have x, which is equal to 2 point, lining up those decimal points, 9102, 102, 102 repeated. Some of you might have actually questioned whether this worked, because when you look at the repeater symbols, they look quite different. This one's 102 and this one's 210. But when we wrote one equation above the other, the numbers lined up nicely. And we know we can cancel these now. Being careful not to cancel the 2 and the 9 here. They don't cancel. Alright, I should have shown that I'm subtracting these equations. Doing the left-hand side, 1000x minus x is 999x. How do I subtract the right-hand side? I've already cancelled out the repeating decimals here. Well, to be honest, I'm just going to use a calculator. 2910.2 is what I have at the top, and I'm subtracting 2.9, which gives me 2907.3. Alright, now we need to divide both terms by 999. This will cancel the 999, giving me x equals 2907.3 over 999, remembering that you're not allowed a decimal. And I can fix that really easily. I just times both the numerator and denominator by 10. And I now have 29,073 over 9,990. And I can double check that here. 29,073 divided by 9,990. And here we go. I've got 2.9 and the 102 starts to repeat, which is exactly what I wanted. Anyway, that concludes our video on example 1. Remember to read the description below for links to workbooklets that relate to this video.